if you've heard of Flow, then you probably heard of Dapper Labs. So Dapper Labs is the company where the Flow project was started, and the engineers at Dapper Labs have a deep background in blockchain, and especially mainstream blockchain. They built CryptoKitties back in 2017, which was sort of the viral app on Ethereum, and it's still one of the largest dApps still running on Ethereum. I saw the other day that they're close to something like 7 million kitties or something like that, a ridiculously high number. Those are NFTs that have been minted through that app. So leveraging their experience building on Ethereum and some of the problems that the team encountered while trying to deliver sort of an app with ambitions of reaching mainstream users, decided that it wouldn't be possible to do on Ethereum. And then that's sort of the genesis of Flow is that idea that they tried to deliver CryptoKitties, make it an experience that everyone could have, and ultimately was Ethereum was the limiting factor. And it still is. So we conceived of Flow as sort of the first blockchain for consumer apps, and there's an interesting architecture, interesting network architecture that makes that possible. But the network architecture and the blockchain itself is only one piece of the puzzle. If you can have a great blockchain, but if you have, if it's hard to build anything on it, you can have a really fast, really powerful smart contract language and so on. But if you don't have the tools to build anything, or if it's difficult to get started, then you're holding your project back. So we're trying to do both things. We're trying to make a ridiculously fast and capable blockchain, but we're also trying to build tools on top of it that are easy to use, familiar. Yeah, that's sort of what I'm going to show you tonight. And so our first we're proving out our blockchain and our tooling on this app that you may have heard of. So Topshot we launched back in January, and that's since gone sort of viral, and there's a feedback loop there. So everything that's happening, the scale, the kind of the amount of interest, the amount of the volume of transactions that are running through Topshot are sort of informing how we're building the blockchain, and also some of the problems that Topshot developers are running into in terms of doing the things that they need to do from the client application on the blockchain is informing the tools that we're building. Cool. So I'm going to show you guys quickly how to build a dApp tonight, but maybe it makes sense to think about first, what is a dApp, or when I'm talking about why do we want to build such a thing. So for me, dApps are about trust, and we can break down the sort of trust idea into three categories of applications that we sort of call dApps. So in fact, there are two categories. So there's apps that we use, which are just the regular apps that we're used to using, which are, we'll call them fully centralized apps. Any software as a service, pretty much any application that you interact with from your web browser or on your mobile phone, et cetera. Anything that connects to a central server to provide data, to hold data for its users and so on. Closed source, et cetera. So these are the typical apps, and they're fully centralized in the sense that user data is stored on private servers, and apps, usually centralized apps, don't compose well directly with other apps. We'll see what that means in this demo, this idea of composition. The next category is sort of like partially decentralized. So this is what Topshot is, the partially decentralized app. So they have some, Dapper Labs, of course, has servers with user information and other things on it. But then there's the blockchain component as well, which holds the NFTs. And then there's bridging technology, bridging systems between those two stacks. And we call this sort of a hybrid dApp. And these are very common. In fact, they're very common on Flow at the moment. But we sort of, the hybrid apps are also somewhat controversial. People hesitate to call them dApps because the D in dApp stands for decentralized. I'm on the side of, hybrid apps are dApps because they use decentralized technology in a way that's fundamental to the application itself, and not a side concern or not a novelty. NFTs, the example Topshot, NFTs are on the blockchain, and the NFT is focus of the application. So we call those hybrid dApps. And then the final category would be like a fully decentralized application, which does not use a private server. So in the simplest explanation possible, it doesn't use private servers, source code and business logic. That is, the smart contracts are deployed on a public blockchain. They're publicly viewable to anyone who has the address, and so on. And then the interface to those contracts or to the blockchain backend is a UI that is also sort of a static website that can be deployed on a static file hosting service in a decentralized way where you're not relying on any third party for the uptime for your front end of your site. So those are sort of how I'm thinking about dApps. This is how we're thinking about dApps at Flow in general. Tonight, we're going to build a very sort of generic, fully decentralized dApp. So that is, we're not going to use a web server. We're going to use a static front end, and we're going to use the client library to talk to Flow and to do things, to compose smart contracts into the user interface and run transactions in the blockchain and so on. Cool. So when I say dApps are about trust, and more specifically, what I'm talking about is this idea of trustless computation. And this is an interesting idea that we talk about when we talk about blockchains, but specifically blockchains that can run smart contract code. So the code that is being run, being executed on the blockchain is actually not, we can say it's being run in a trustless way, in that the results of the computation are verified by a network of participants. And there are Byzantine fault-tolerant, Byzantine protection mechanisms in there, which sort of make the computations that you run, the results of those computations get verified by the wider network. And so we have some guarantees that the programs that we deploy on these blockchains are sort of incorruptible in that way. Cool. So how do we build these trustless? How do we build programs that we can do trustless computation on a distributed computing network like Flow? On Flow, we built a language. So we'll demonstrate that language tonight too, which is this is probably the most exciting part for me. I really like Cadence because I really like the idea of writing smart contracts. And so we built, not only did we build the blockchain, the dev tools, but we also build a smart contract programming language from scratch. And we call it Cadence. So we'll show that tonight. And then the final piece of the puzzle is this thing we call FCL, or the Flow Client Library. It's a JavaScript a client library. Flow also has client libraries for a number of other languages, but JavaScript runs in the browser, so it's a really great tool for building these fully decentralized applications where we don't need to run any code on servers. We just communicate directly from the browser to the computing network and then back to the browser. So we're going to do some trustless computation. We're going to use Cadence and FCL, and we're going to submit our computations to this world computer. You may have heard that if you're coming from the Ethereum world. It's this idea that we have this sort of computer that doesn't owned by anyone, but it's owned by everyone who's using it, takes part in sort of verifying the computation that's taking place there. And it's a peer-to-peer, it's a distributed network that actually runs the computation. So if you're curious about the actual architecture of Flow, I encourage you to read the white papers and the documentation. Flow has a unique architecture that involves different node types. And we call it the world computer, or the metaverse. And this is our CEO, Deep. He's saying smart contracts inside this world computer are actually immutable sort of public APIs. And not people tend not to talk about that. And we'll see exactly what that means in the demo tonight. Cool. So we're going to build on top of these on top of the world computer, on top of these smart contracts that are already deployed. We're going to use Cadence to write transactions to interact with these programs. And we're going to see how that works through a user interface based on a Vue app. Cool. Okay. What's my time here? Okay, so we're getting through this pretty quickly. All right, so what I've decided to do, and what I think will probably work best, is we're going to do this sort of code along style. And we'll just go from very simple to just sending an interaction to the blockchain, and then we'll build on that. We'll add authentication. So we'll see how we can integrate a wallet, and then a custodial wallet, and then we'll finally we'll import a contract. We'll bootstrap our account with some resources from the contract that we import. Okay. So is everyone game for something like that, or were there any questions before we get into it? Okay. All right. So if you want to follow along, what I can do is I can share the Code Sandbox link with the group if you want to view. And then at the end of it, I will give out, I'll give the link to the finished app so you can look at it and sort of play around with it yourself. So yeah, I just went into Code Sandbox. I clicked on the brand new View app, choosing View because we're going to do everything in sort of one file, and View is sort of easy to use. And I'm kind of bored of React. Everyone does something in React, and I'm sure if you know front-end development, you can easily sort of port what I'm doing here into React. There's nothing about the client library that is specific to React or Vue, et cetera. It's just it's sort of agnostic in that way. Cool. All right, so we'll do everything inside of this Hello World component. So right now, this is what the website looks like. It's just the template from Code Sandbox. This is a Vue app. I'm just going to go ahead and just get rid of everything inside here. And so we'll start fresh. So last time I tried to do this, this is where everything stopped working. So hopefully that's not going to happen tonight. And then if we reload this, great. So we have, great. So this is working. So this should just be a blank page when we're done. Awesome. So the first thing I'll do, and the first thing you'll do if you're building a dApp on Flow and you want to talk to Flow from your JavaScript app, is install the Flow client library. So that's what FCL stands for. That's what you'll hear us call it. That's what the package is called. So I'll go ahead and install that, and in Code Sandbox, you just, by the way, feel free to stop me or ask questions as we go here. So we'll add two dependencies. So it's onFlow FCL, and then we'll also need onFlow types, and we'll explain why later. Okay, so those are the two libraries that we're going to use to build to communicate with Flow. So just add those quickly. Great, and now they're installed. My head's blocking it, but yeah, you can see. So I realized my head was blocking that the whole time, but you can install onFlow FCL here and then onFlow types. So when you have those added to your project, you can come into the script block and you can import it. Great. Cool. So with that, we now have installed the Flow client library, and we're ready to communicate with Flow. But before we can do that, the Flow has something called an access node. So to make requests from the browser to Flow, you'll be making those requests through a node in the network called an access node. And so tonight, the app that we're going to build is going to use the testnet. And so I'm just going to tell my app how to connect to the testnet access node so that we can send messages, send scripts, and Flow transactions through the access node to the Flow network. And the way we do that is we just come in here and we can say fcl.config, and then we'll put, and then there's a special property called access node API. And then the value will be the address of the flow access net, which is this one here. So it's https access testnet and flow.org. Great. So that's all we need to do. Now this instance of the client, the Flow client library, understands where to send messages, how to interact with Flow. And interesting part about Flow is, so with Ethereum, didn't come with an HTTP access node, enabled access node. On Ethereum, commonly, you would use something like Infura to do this. So on Flow, if you're familiar with Ethereum development, with Flow, we built the access node for you. So you don't have to pay for it or get tokens or anything like that. Great. So now we want to send a message to Flow. And what we're going to do is we're going to send first like an arbitrary computation, just to prove that this sort of network computer is real. We're going to send some computation. Maybe we'll add something to the network, and then have the network return us the result. Just to demonstrate simply how this will work. Cool. So the way we can run computations that aren't transactions on Flow is by using something called a Cadence script. So and so we can create one here in JavaScript using this fcl.script method. And then inside the scripts, every script, a Cadence script begins with a main function. And we can just simply return some arbitrary computation. Okay, this is going to get much more interesting, but just to test that our client is connected to the network, and that the execution nodes on Flow will receive the script and run the computation, give us the result. Cool. So now we want to send this script. So what I'll do is I'll just create a function called send, and then I will, inside of it, send the script. So we can go fcl.send, and then pass in our script. Oops, I forgot to assign this. And then we'll go here. We'll decode it. This is the async function. Okay. So nothing fancy here. We'll send the script and then await the result. When the result comes back, we will need to run this sort of FCL decode function on it. And what this does is it takes the response from the blockchain and transforms it into a value that JavaScript recognizes. And then we're going to just console the log the result. Cool. And I want to trigger this from the UI. So let's add a method. And we'll call that one send, and then I'll just use send. Cool. And then in here, I'll just make a button. And then this is just view syntax. Great. Now we have a button. When we click it, it will send this script to Flow, and then we should see something in the console. So let's go ahead and save that. And then if I've done everything right, element. Oh, bottom. That's it. Bottom. Typo. Great. Now just reloading. And since we're console.logging that, I'll just open the console here. Ooh. And then we should get the, should reload eventually. Oops, I'm terrible at HTML. This needs to be a closing tag. All right, am I doing this right? Sorry about that, guys. Later. Okay, so here we go. So let's try to send the transaction. Let's try to send the script to Flow. And this is like the full interaction. So from the user clicking a button across the network using the gRPC protocol that the access node understands, that Flow understands, into the network, computed by the execution nodes in Flow, and then sent back to the browser. So I'll just click send, of course. Okay, so what do we have? Oh, okay, it's telling me I forgot to the return type. Easy. So I just forgot the return type from my script, so that should work now. I'll do that. Oops, and I suck it. Just forgot to capitalize the I. And here we go, third time's the charm. Expected, oh, got it. Okay, so it's just telling me I'm being too overzealous with my type. It's just an int. It's not any kind of unsigned integer. So let's just save that. And then eventually we'll go. Hey, there we go. So I don't know if you guys can see that, but there's a 4 here. So this may not seem like much, but indeed it's this computation that I sent was run by the world's computer. So this computer is not owned by anybody. It's a result of the participation of a bunch of different node operators who are running nodes, and the consensus protocol and the verification protocol and so on, making sure that I get the correct result back. And this is very simple computation, but you can imagine you could extend that to any type of program that you can think of. Cadence is just a general programming language. Cool. Any questions, or we'll just keep going? Cool. Great. So the next, so that's interesting, but this sort of computation is arbitrary and it's kind of hard-coded into my script. It'd be more interesting if I could take values from the web page, like a real app, take user input, and then send those user inputs to the blockchain and have those user inputs get computed on by Flow's distributed computing network, and then return me some value. So we'll do that next. So we can simply add arguments to our script. Okay. And then I'm not going to bore you with building a user input. I'll hard code the values in JavaScript, but I'm going to assume that you can sort of understand how you would get those values from a user input if you needed to. I think the important thing is that these values come from JavaScript. So they could come from arbitrary user input as well. Cool. So to write arguments for your script, we're going to sort of modify this send method slightly. So what we need to do inside the send method is we have a script that we're sending, and then in the second position here, we can sort of specify some arguments by using fcl.args. This is a special function. And sorry, fcl.arg. This is like a special function. And it takes two arguments. It takes some JavaScript value, can be any value. For now, we'll just use a regular number. So again, imagine you pulled this number from the user input and you put it in this function. And since we have two arguments, we're going to wrap it in this sort of args function, which takes an array of arguments. So we have the first argument is 5, and the second argument, let's say it's 5. Great. So the second thing we need to do is give FCL a little bit more information about how to take these JavaScript types, in this case, primitive type like a number, and convert it to a type that Cadence can interpret. The way we do that is by using another package, the second package that I installed. From Untitled Chapter. I used it. Great. Okay, and actually we shorten this down to T because we're going to use this in our function. So here we have this 5, and we know it's T.int. Easy as that. Great. And this is not happy, but we're just going to ignore that because I think it's fine. Great. All right. I'm missing a bracket, something's going on here. Awesome. Hey guys, I just have to step out for one second. Sorry. Sort of that. Someone's trying to get in. Okay, so getting some errors here. Let's rewind this for a second. So we have scripts, and then we have args, which is a function which takes an array of arguments. 5 of type int, and second argument, we'll say it's 5 of type. Okay, great. Let's save that and run it. Let's just see if I've done this right. Int is A, and then we're returning int equals B. Send the script, and then the args. Maybe it hasn't reloaded fully yet. Let's see. Oops. Let's try just rerunning quickly. So once this works, what we'll do after is we'll actually do something more interesting. We'll import a smart contract. Actually, first we'll demonstrate how easy it is to add a wallet authentication. It's basically 2 lines of code, and then we'll import a smart contract, and we'll add some resources to your account. So let's try this again. So this looks like it might be something to do. So I'm not going to try to debug this right now. I think there may have been some changes to FCL, since the version I'm using in my other project is a bit lower than this. I'm not going to fool around with it. I think maybe I'll try one more time. This is a bit confusing, so maybe I'll do this. That's because just to make it easier to read. Great, I think that is the correct syntax. Yes, it is. So I'll put those in there. Reload it. If this fails, yeah, okay. So there's something is broken. Let's move on to the authentication piece. And we'll keep this here for now. Just commented. Great. Okay, so that's all fine and good. We can send computation to Flow, but what we really want to do is our apps aren't just we can run computation in the browser. It's not super useful unless you like to sort of think about your computations being run in a verifiable peer-to-peer distributed network instead of in Chrome. But probably you don't care about that. Probably what you care about is building apps for users and doing things like minting NFTs and creating value using the blockchain. So let's take the first step in that direction, which is authenticating our users using FCL via a wallet. And the way we do that is we add one more bit of configuration. So we have to tell FCL how to communicate with using a protocol that we developed for talking to third-party custodial wallets. So if we tell FCL where to go to look for which compatible wallets are registered with our network, we can do that in a single line of config. So we'll just put that on a new line. We can chain these put methods together. And there's another special value called challenge.handshake. And there's also a special URL. And what this does is it tells FCL where to find wallets that are compatible with testnet, and it will show them to the user. Great. So now that we've configured FCL to use wallets, we have methods that we can call to log the user in. And so let's go ahead and do that. So we'll create one method here. We'll call it login, and we'll call it. I think it's capitalized like this. Great, and then we'll make this available to our view. And then I'll replace the button here to call the login method. Great. So with that, we should be able to log into FCL, and we'll describe what happens as we do it. And we'll comment this up for now. Great. Great. Oh, it still says send, but it's going to be login now. Maybe that just turns out. Just so we're clear. Great. Okay, so now we should be able to click this button. And the user is presented a list of wallets that are compatible with Flow. So here you can see these are currently the main sort of user-facing wallets that aren't exchanges that we can use to allow our users to create Flow accounts using our app. So the account model, of course, is a little bit different on a blockchain. You aren't responsible for your users' accounts. Your user is creating a Flow account. The wallet is holding the keys to those accounts, and the wallet is authorizing your app to take some action on behalf of the user. So we'll go ahead and use Blockto since I don't have my Ledger device with me, and Dapper wallet isn't quite ready yet. So just click on Blockto. I've already signed in this browser, so Blockto is smart enough to sort of have preserved some information about my session. But you can, if you're following along, you can go ahead and enter your email, and Blockto will create a testnet Flow account for you at your email. There'll be a confirmation code and so on. I'm just going to go ahead and confirm. So nothing happens, but that's good. It means that I'm logged in. So what exactly? So I'm logged in. What exactly does that mean? So it means that the FCL now has some notion of the current user. So basically, it establishes a session between Blockto and Flow and the browser. And that session will include information like the user's Flow, newly created, or already existing Flow account. So let's show some of that in the console. So the way we can do that is we can call this FCL.current user method. And what FCL allows us to do is to subscribe, because we all like some reactive programming. And then we can pass in a callback here, and this is a function that will get called with the user object when the user logs in or logs out. So we don't have a function to do that yet, so maybe I'll just define it in line here. Or let's just say set user. And then over here, I can find that. And this will be the user from FCL. And then you can see. Awesome. And I also want to be able to log out so that I can show you this set user function gets called in a reactive way. And that's as simple as FCL. Okay, let's make this logout button available in the UI. So I'll just add a method. And then I'll make another button. No fancy logic. Both buttons will be viewable at the same time. Okay, so let's go back here and let's watch our console. So if I reload the page, I should see the user get rid of all that junk. There we go. So once this reloads, great. So it reloaded. Since I've already logged in, there's already a session with the wallet. So there's already a user, and the subscribe method logged that for me. And here is how FCL is representing a user. And you can see here in this address column or adder property, this is the flow address of the currently logged in user. And we have also some nice convenience properties here that we can use to in our user interface, logged in, logged out, and so on. And then some other identifying information that is used by the wallet protocol. Cool. So with that, we've effectively logged into the application, and we have not only the user's address, but now we can communicate with the wallet and allow, and because we've established a session, we can now allow the wallet to take some action on behalf of our user in communicating with the Flow blockchain. So what that means is running and signing transactions. So transfer tokens, mint NFTs, and so on. I'm just going to log out just to show you that. Oh, they both say login. That's awesome. I'll say that, but it should still work. Let's log out. Oops. Of course, login is camel case and logout is not, but that's fine. Oh, I see. I got that wrong. So unauthenticated. So this will remove the session from the browser and disconnect you from the log. Any questions so far? You guys, what do you guys think of all this? Interesting. Great. I'll take that as okay. So we're reloaded here. If I log out, then I'm back to, and now I've cleared the session, and you can see I have the current user object, but we have null address, and logged in is also null. So this is the session now. We can log in again, and it will pop up the same UI. I'll use Blockto. It knows that I had a session previously. I can confirm, and now I'm logged back in. So you can think of this as the equivalent of, sort of the equivalent of what MetaMask does for you for Ethereum, except in this case, it's not a browser wallet. It's the keys are managed by Blockto. So this is a non-custodial wallet, but it's effectively serving the same purpose as MetaMask. It's allowing you to send transactions to Flow, sign them, and those transactions will be signed by your Flow account. So if you're interested in the options that Blockto gives you, if you're more thinking about non-custodial and you wanting to have control of your keys, go and check out the Blockto wallet docs, and they do have options for migrating your wallet from semi-custodial, which it is now, to fully non-custodial, where you have the keys and so on. Great, so we've come a long way. We've added with one line of configuration and two functions, 3 functions. We've sort of added authentication and authorization functionality to our application. So let's use that. Let's actually build a transaction, assign it, and send it to the blockchain. Great. So what we're going to do is we're going to sort of use an already deployed contract, and we're going to take that contract and we're going to use it to as part of our application to provide our users, our application users, with an extended profile, a profile that they control, that is the resource that gets stored in their account, but that's generated by a contract that somebody else deployed. So it's effectively, I'm using a contract that I didn't create to give the users in my application some benefit that contract provides. And this is the thing I was talking about at the end of my introduction, this idea that any smart contracts deployed is effectively an immutable public API. So we're going to look at the contract for a second, using this tool called Flow View Source. And I'll put in the contract address that I'm interested in. It's this one here. So this is an account that is deployed on testnet, which has some contracts already deployed to it. I looked at them and I saw this profile contract, And I said, heck, that would be great. I want to give my users a custom profile for my application. And there's already sort of one here that I can build on. I'll share the link if you're curious and you want to look at this yourself in the chat. So this is the contract we're going to use. This contract is great. It has extensive instructions about how you might go about using it. So we'll just follow these instructions and sort of implement it ourselves. If you're curious about how the contract works, I encourage you to look through. This account has some pretty cool contracts in it. It'll give you an idea of what a smart contract written in Cadence looks like. Because we don't have a lot of time tonight, and Cadence is kind of quite a wide topic, I'm just going to use this contract and talk about how you can do that. But definitely check out Cadence. Like I said, it's probably the most, it's probably the thing that makes Flow a really good option for building your dApps. Very easy to use, easy to understand, and general purpose programming language, unlike a lot of other smart contract programming languages that are emerging in contemporary blockchains. Cool. So first things first, we need to somehow tell FCL that we want to use that contract. So in my code, I'm going to add one last final line of configuration. I'm going to say, I want to use this profile contract. I'll give it an alias. The OX is meaningless. It's just a convenient way of aliasing contracts because flow addresses start with a 0x prefix. Oops. And then I want to specify the address so that this is the address where that contract is deployed, and this is how FCL will understand how to talk to that contract. So I'll just grab the address here. I'll just highlight it, copy it, put it in my code. So I'm telling FCL I want to have this sort of, I want in my Cadence code, in my scripts, I want to be able to say 0x profile, and then I want it to resolve to this address. So what the heck does that mean? So what this will let me do is now write a script that I can use to import this contract and then call methods that this contract provides. So we can do that quite easily. So we can say, we'll try this script again. Hopefully it works better this time. And every script, and we'll do a transaction right after this. So let's see, 8:22. Okay, that's not the time. Put from main. Man, cool. So in our script, we'll import the profile contract from our alias. Cool. Now, this profile object will give us access to the methods, like I mentioned. So the one we're going to go for at first, let's just scroll down here. Here are the public methods that we can call on this contract. So let's just say, let's say we want to call, and here are some other ones. So we want to fetch, we want to read. Let's use this read method. So we're gonna pass in our address, and this is gonna basically check if our address already has been assigned a profile. And I just have to check that, okay, so this will return a profile.read only. Okay, so then my script has to return that type. And this is an optional, so if it doesn't find the profile, it's just returning nil. Okay, great. So I can say, oops, I put the import inside the function body. Of course, it goes up here. Okay, so I can say return profile.read, and I'm going to pass an address as an argument into the script. We saw that syntax for passing arguments in the previous demo, which didn't work, but hopefully this will work. And then we will say, we'll say profile.read address. And so, and then of course we have to specify the return type, which is profile.read only. And then that's optional. And I'll just, and we can double check that that is correct. Yeah, I'll just copy this. Cool. All right. So let's rewrite that send method. Let's rewrite that send method. So we have to do two things. We have to provide the address for our Flow account. So we saw how to do that. We have the address on the user profile object when we log in using Blockto. So what we need to do here is make that value available to the send method. So the way we'll do that is we'll do like a little view thing, which is we will use this view thing called a ref. Cool. And then we'll say great, because we may want to show this. I'm using this view ref thing because we may want to actually expose this to the user interface. We want to just show the profile once we have it. We don't just want it to be like a variable inside of this script. We want to actually sort of connect it to view. So that's the only reason I'm doing this. Great, and that's about it. And so what I want to do is, instead of console.logging, I can just say profile.value. Cool. So whenever, so this ref is like a reactive variable. Reactive variables in Vue are just objects, and there's some like something behind the scenes watching the reference to this property. So it works just like regular objects assignment. Great. And so with the send method, what I can do is rewrite our FCL send. And we have the script that we want to send for reading the profile, and then some args. Okay. So what was it? Oh, of course. Okay, so we'll create the args. Oh man, I hope this works. So arg. This will be user.value, which would be that user object add address. And then the type, so we'll re-enable this, and do t.address. So this is a FCL knows what a flow address is, and so Cadence knows what a flow address is and provides a type for addresses, for flow addresses. So we can, in our Cadence code, we can type our parameters using that type. And so with the FCL, we have to also specify the type as well. And let me just check my. If this doesn't work, I'll just downgrade FCL and then. Yep, that seems to be working. Okay. Why doesn't it like this? User. Oh, sorry, it wasn't user, it was profile. Yeah. Profile. Okay, let's continue. let's just do this. Do we have optionals yet in JavaScript? Yeah, we do. Okay, so okay, sweet. So let's once we do that, then we have to decode and we'll console.log it. So log and then mcl.decode. Sorry. So the result should be no, if this works. And just to be safe, I'm going to go back to the one that was working in my previous demo. So there we go. And then I'll expose this method again to the view. Login, logout, same. Great. And then I'll create a button. And this will be yes. All right. So we're going to send this script that imports the contracts. We're going to pass in the address. Oops, that got deleted. And this function will return a profile if a profile exists at that address. And then we provide the value here. Maybe just go, yeah, let's go back to wrap. Okay. And if this doesn't work, what we can do is I can just hard code my address here. In fact, let's just do that. So my flow address is, I don't know. So let's see what that is. Okay, let's just try this. I should have copy and pasted it somewhere, but I didn't. All right. So reload everything. This should install the working version of FCL. This just takes a minute. So while we're waiting, does anyone, have any questions or anyone? Everyone's muted, so I'm not sure if you're talking or. No, okay, that's fine. Okay, we should be back in business. So I'll send this. Expected address for type address. Oh yeah, because we're not logged in. Okay, so that makes sense. So let's log in first. There we go. I'll log in with Blockto. Now that profile should have a value. So if I click get profile now, no, I should have logged. Let's just quickly do this. I just want to get the address because this isn't working. I'll just put my address in there, hard coded. Here it is. So I'll just copy this. This is my flow address. And I'll build this. Oops. Great. Save that. Come back here. And let's go. Let's reload. There we go. So it just so happens that when I was here, we'll do that again. So I've already deployed a profile to my account. And so when I put my account address in and I read from my account's storage, I have a profile. And so if you look at the profile contract, you'll see that these are the properties that contract lets you add to your Flow account effectively. So this profile is sort of an object, which we call a resource, which gets stored in a special path inside of our Flow account, inside of our Flow account storage. And so any smart contract that wants to store some information attached to a specific user account can use these storage paths. And so the profile contract sets these storage paths here. So these are fairly generic. This is probably not a best practice because you want to make these paths sort of specific to your smart contract. So public profile might be too general, but in this case, this is just a demo, so that's indeed what they are. So this information that you're seeing here is actually an object called a resource, which was created by Cadence and stored in my Flow account's storage at the path specified here in public profile. Cool. So we did indeed. So this is a simple get operation. So there's no authorization required. We're simply reading public information from the blockchain again. And thankfully, what downgrading worked, and we're able to pass the address in. But what we really want to do, so this object is attached to my account, and the profile contract gives my account some special privileges when it comes to updating this profile object, meaning that basically only my Flow account is allowed to authorize updates to any of the information here. So that's the final thing we'll try to do. We'll write a transaction that goes to my account and modifies some information in this profile and asks me for authorization through Blockto. And this will be in a transaction. And this is the real thing. So we'll go back to this. We'll go back to the contract and we'll look for the method for updating. There's some complicated stuff here. Okay, it looks like we have some setter methods. And so if I'm the owner, which I am, I should be able to let's set a color. Great. So let's see if there are instructions about how to do that. Check if account is initialized. So that's what we did. Oh no, we didn't actually. We directly fetched the profile and it existed. Let's see. I'm looking for instructions about how to. This is what we did. We did profile.read. And I'm sorry if this is really small, but so let's see if we can update an account. This is verification. Okay, so here's an example of what we're going to need to do to call one of these public methods as the owner for a specific account that I am. So I'm just going to copy this. This is very convenient. And I'm going to come back to my application, and I'm going to create a folder called Cadence. And then in there, I'm going to create a file called, oops, it's up here. I'm going to create a file called transaction update. Cool. And then I'm just going to paste that in, and I'm going to add my imports. And I'm going to import we're using types here, so we need that types library again. From onflow types, right? Great. Cool. So and then I'm going to export a function. Date profile. And then I'm going to put this block inside there and return it. Great. So there's a lot happening here, and we'll go through what it means to send a transaction on Flow. So the first thing I'm going to do actually is that since we're calling the set name function in this transaction, maybe I'll just change this to update profile. And then here you see the structure is the same as a script, but there are a few more sort of components to a transaction. So here we have the things that we did when we were running a script. We provide the cadence code, and then we provide a means of taking some JavaScript and applying it as to the parameters that we've defined. Transactions are structured a little differently, but you can see that the name is the parameter here that I'm passing into the transaction from JavaScript, and it's of type string. So the other components of a transaction will go from bottom up. So at the bottom here, we have something called a limit. This is basically, so on Flow testnet, actually, so Blockto wallet pays transaction fees for our users. But this is a way of, similar to Ethereum, sort of setting a gas limit, or how much computation, you can think of it as how much am I willing to spend on this transaction? And if the computation inside the transaction will cost more than this, then don't bother running it. So similar to gas. Transactions on Flow will be much cheaper than they are on Ethereum, just given the design of the system. And then a Flow transaction can have 3 different authorizations. So in this case, my account will serve as all 3. So I'm proposing the transaction, I'll be paying for the transaction, and then I'm also signing the transaction, which is essentially authorizing it. But Flow is set up to accommodate out of the box multiple signatures on transactions, and it's also set up out of the box to accommodate multiple to accommodate sort of third-party payers on a transaction. So this FCL.authz, this is sort of a special object which is a special function which is communicating with Blockto, and Blockto's Flow account has some Flow in it, and Blockto will in fact be paying for this transaction. But you can put any sort of a Flow account into this payer function, and that account will then be charged for the transactions. It's very convenient. And then the proposer has to be the same, has to be among the authorizers as well. So proposer and authorizer have to be one and the same, and then there can be multiple authorizations as well. It just means the transaction can be signed by multiple different Flow accounts. So if you may have a scenario in your mind where you want to submit a transaction that is signed by multiple parties. In this case, it's just me. I'm paying for it, I'm signing it, I'm authorizing it. So I'm going to change my name to Matt. And with that, we're ready to send this transaction. So the final thing I'll talk about is this prepare block. So transactions have, and I encourage you to go read the documentation, but essentially the prepare block in a transaction gives me access in the Cadence code to the account that is authorizing the transaction. So this is my Flow account. So this is sort of like the block of code where you can do things on behalf of your on behalf of a user's Flow account. So in here, this account will actually be the account that signs the transaction. And if there are multiple authorizations in this function here, you would indeed have be able to add multiple Flow accounts here, and then be able to ask them to do to be able to access their storage and do things on behalf of them in Cadence right here. So in this case, it's just the one authorizer. It's me. So I'm able to read the profile information from my private storage. Remember, there were two paths. So as myself, I want to be able to. I'm okay with myself having access to things which are private to my account, and so I'm able to do that. And then I'm basically saying borrow the profile owner, borrow the profile, a reference to that profile resource that's stored as the owner. So this is the interface notation. This is called a capability, actually. So borrow that profile as an owner from, it should be living in the profiles, in my account in the profile.private path that was specified by the smart contract when we added the profile to my account. Once we have that profile object, call the setName method and pass in the name, which we've passed in via the argument here. Okay, so there's a lot there, and I encourage you to take a look at Cadence. Again, capabilities and resources are really the fundamental building blocks of Cadence, and it's how you do things like create NFTs. So this profile here could easily be also an NFT if you want it to be, or anything you can think of, any object, fungible or not. So now that that's all sewn up, I'll just save it. And then we'll go back to the view, and for our final thing, we'll import this function. And you know what? Let's take the name as an argument here to the function. Oops. Okay. I'll say that. Great. So if I come back here, and I'll just import that function. So let's. Where did I put that? That's in back. Cadence. Great. And let's just create a function. That calls this. This will be an async function. Okay, profile name. And we should be able to translate that. Great. And then we'll add a button that does this. And again, and I'll pass in the name here. And again, just for simplicity and time saving sake, I won't wire up a user an input in the UI, but I'm sure you can imagine how, if you're familiar with front-end development, pulling in this string of text here from a user input in the user interface. But we'll just hard code it here for now. And then we'll make this method available on a button. And oops. Great. Okay. And looks like everything is working. So let's give it a shot. So let's run that transaction. Okay. So FCL has told Blockto, hey, this user wants to run a transaction. Inside that transaction, there are some actions that require the user to authorize those actions, namely this reading of the profile from the profile's private path. So Blockto understands that it needs to get my authorization in order to do this. And so that's what's happening. FCL has triggered this window. It's going to show me the script. So here's the script. So it's saying, oh, okay, here are the arguments to that script. It's the string Mac, and here is the actual transaction that the app wants to run. It's going to borrow the private path of the profile, and it's going to call the set name method. So if I'm okay with that, then I can approve this transaction. Blockto will sign it on my behalf and submit it to Flow. So I'll approve that. And because it's a blockchain, it takes a little while, but eventually we should see the console.log happen. And we can even look on, there is a way to get the transaction hash and so on using FCL, which I should probably demonstrate, but so we're just waiting. You can go here. And if I plug in my this is my address. Okay, we won't do that. Let's get the profile again, and well, we can see that the name was updated and that it indeed worked. So there are facilities inside FCL for us to similar to on Ethereum or other blockchains where you submit a transaction, you receive the transaction hash, and then you can watch that hash, and you can see the status of your transaction go from pending, executed, sealed, and confirmed, and so on. So that worked. I was able to update I was able to update a resource which is stored in my Flow account. The resource was put there by my app and authorized to be there by me, by the owner of that Flow account through Blockto. That object wasn't created by me or by the application developer, which also happens to be me. It was created by somebody else. And me as the developer was able to tap into that smart contract, use it, provide that object to my users. And now we've sort of seen we've seen sort of very small hints of the kinds of things that you can do on Flow with Cadence in a dApp, in a decentralized application where you're composing smart contracts, where you're very quickly integrating wallets and doing user authentication. And you're very quickly taking advantage of an existing ecosystem of smart contracts to provide value for your users. And everything sort of happened in a very low friction, except for that FCL version, sort of in a very low friction, very easy to understand way. In fact, we managed to do everything inside of a single view component here without much, without much effort, without much faffing around. So that's the end of my demo. Thanks a lot for listening. Hopefully you got some value out of that. Hopefully you're sort of excited to try this out for yourself. I can post links to, actually, if you're interested if you really are interested in developing on Flow and you want to see something more than just a simple example, we do provide a full stack application, which is a hybrid dApp, meaning there's a server, and then there is also some code like this communicating directly to Flow from the application. It's a similar setup from the web application. It's a similar setup to what is happening in Topshot, just very, very much simplified. It's called Kitty Items. So I recommend if you are interested, and if you're sort of not new to this, if you've heard of Flow, if you've done some poking around, go look at Kitty Items. If you're familiar with the web stack, you should find things here that are very familiar. You'll even see patterns that we went through just now. For example, inside the web app, you'll see there are quite a few flow transactions coded in much the same way, and so on. So if you're really interested in building a full-featured, Kitty Items happens to be an NFT marketplace, but it can serve as a model for many other types of hybrid decentralized, partially decentralized applications. And if you're brand new to this and you're excited about learning more, I would suggest trying out the Flow Playground. So that's at play.onflow.org. And this is an IDE that we built for you in the browser to sort of accelerate your Cadence learning, to help you understand contracts, transactions, scripts, accounts, authorization, arguments, and so on, all this stuff that we sort of very briefly touched on in this presentation. And in fact, we have a bunch of really well done tutorials that will take you from basically zero to building a full featured sort of NFT marketplace. And we'll take you there step by step. NFTs are popular, so you may want to try doing the NFT token, tutorial. And as you can see, it's quite in depth. So you'll learn a lot, and so that's a great resource as well. So try the playground if you're new. If you're sort of wanting to be a bit more adventurous, take a look at Kitty Items, full-featured dApp. If you're not already in our Discord, please join and come and ask questions. And I think actually Megan will provide links to all this stuff at the end. So that'll be it. That's it for me. Thanks for your attention, and hopefully we'll see you in the Discord. And thanks for inviting me and letting me come and show you Flow and some of the work that we're doing.
Awesome, thank you. Before you go, is there any last minute question from Mackenzie, from anyone? If not, thank you everyone for joining. Again, thank you Mackenzie for this amazing presentation.
Great, yeah, no problem. Thank you. Okay.
Yep, good night.
Yeah, I think you have to end the call.